Ever get that feeling, when you're training one of those massive AI models and it's like watching paint dry, just waiting and waiting for it to finish? Well, today we're taking a deep dive into some new metrics from Weights and Biases, and these might actually help you speed things up.
That's right. And maybe even save some money in the process.
Oh, yeah. Always a bonus.
Right.
So we're looking at an article about new TPU metrics, and it's from Weights and Biases Models, and it's actually written by the experts who are working on this problem.
Yeah. So if you're someone who's working with TPUs, this is definitely a deep dive you'll want to stick around for.
Okay, so first things first, TPUs, tensor processing units. These are basically specialized chips that are specifically designed for machine learning tasks.
Right. They're kind of like the workhorses of AI.
Yeah.
Super powerful, but you need to know how to use them properly to get the most out of them.
Exactly. So efficiency is key here, and that's where these new metrics come in. The article highlights 3 new metrics: TPU memory usage in bytes, then there's memory usage as a percentage of total memory.
Right. And duty cycle.
Duty cycle. Okay, so.
Duty cycle is a really interesting one.
Yeah, what is that?
It's basically telling you what percentage of the time your TPU is actively crunching data. If it's low, it means your TPU is sitting there idle, like a worker just, hanging out at the water cooler.
So it's a measure of how much of that processing power you're actually using.
Yeah.
I can already see how this would be super helpful for, figuring out if you've got any bottlenecks in your training process.
Yeah, exactly. And then you can start optimizing things, like maybe adjusting your batch size or tweaking some of the parameters in your model.
Okay, you mentioned batch size. Can you explain that a little bit more, just for those listeners who might not be super familiar with it?
Sure. A batch is basically a group of data points that are processed together at the same time. The larger the batch, the more data your TPU can handle in one go. But there's a trade-off there.
Oh, there's always a trade-off.
Larger batches take up more memory.
Okay. So you've got to find that balance.
It's exactly right. You want a batch size that's large enough to keep the TPU busy, but not so large that it overloads the memory.
It's all about finding that sweet spot.
Yeah, and these new metrics can help you find that sweet spot much more precisely.
Interesting.
So in the article, they actually give a really great example of this. They were fine-tuning a Llama 3.18B model, and they were experimenting with different batch sizes.
This is a large language model, right?
Yep, exactly. And they wanted to see how it affected memory and training speed.
So what did they find?
Well, they found that increasing the batch size from 8 to 16 actually significantly sped up the training.
Oh, wow.
Without a huge jump in memory usage.
So they found that sweet spot.
They did. They made the TPU work harder without, breaking the bank in terms of memory.
That's impressive. So basically they're getting faster training without having to pay a big penalty in terms of memory. Really cool.
Yeah. And it shows how useful these metrics can be for optimizing your training process.
Right, because like you said earlier, every model, every data set is going to be a little bit different.
It's different.
Right.
You need the tools to figure out what works best for your situation.
Absolutely. This is super valuable information for anyone who works with TPUs. Really, no matter what your experience level is.
Absolutely.
So we've talked about speed, we've talked about efficiency, but there's another really cool thing about these metrics, and that is you can actually monitor them in real time.
You don't have to wait till the end.
Exactly. So you can actually see how things are changing while the model is training. It's almost like having a live dashboard for your TPU.
Yeah, you can spot problems before they even become, big issues. You see the memory usage going up too high, you can adjust on the fly.
So it's all about having that fine-grained control over your training process.
It is.
Okay. So we've talked about speed, efficiency, and now we're talking about control. It sounds like these metrics are a game changer for anyone who's working with TPUs.
I think so. And we're just getting started here. There's so much more we can learn about how these metrics can help us understand what's going on during training.
And become more effective machine learning practitioners.
Exactly. That's the goal.
Okay, so we've talked a lot about how these metrics can help optimize, individual training runs. But I want to talk about the bigger picture. How can these metrics help us plan and execute entire machine learning projects better?
That's a great question. And that's something we're going to be exploring in more detail as we continue this deep dive, so stay tuned.
Yes. Stay with us. There's so much more to come.
There is. Thinking about planning these big machine learning projects, this reminds me of this one project I was working on, and we were trying to train multiple models, at the same time.
Yeah. I've been there. It's like, juggling all these different models. It can get pretty overwhelming.
Right. And we didn't have these granular TPU metrics back then, so it was a lot of just guesswork.
Just hoping for the best.
Yeah, pretty much.
So how did these new metrics change things for you in that kind of situation?
Well, for one thing, we could actually see, how each model was using the TPU resources, like which ones were memory hogs and which ones were more lightweight.
So you could actually allocate resources strategically instead of, just throwing everything at the wall and seeing what sticks.
Right, exactly.
Yeah.
It was like having like a control panel where we could see exactly how much memory each model was using, and we could adjust things, on the fly.
So you could actually run more experiments in parallel without overloading the system.
Yeah, that's right.
So it's not just about optimizing individual training runs anymore. It's about optimizing the entire workflow.
Right.
It's interesting, though. These metrics can also tell you something about the model's behavior itself, not just the hardware.
Oh, yeah, definitely.
So you're not just looking at the TPU, you're actually getting some insights into what's going on inside the model, right? So, for example, if you're looking at that duty cycle and you see that it's consistently low for a particular model, well, that might tell you that maybe the model's architecture isn't really a good fit for the TPU, or maybe the data is structured in a way that's causing bottlenecks.
So it's like a little clue that something might need to be adjusted.
Right. Maybe in the model itself, maybe in the data.
Yeah. It's like you're getting this window
to
the model's inner workings.
I like that.
And you can start to diagnose and address these problems that you might not have even known existed before.
It's pretty cool. Right. And, this idea of understanding the model's behavior, it can actually help us build better, more robust models from the ground up.
Okay, so we're not just talking about optimizing existing models. We're talking about using this information to actually design better models in the first place.
So let's say you're designing a new model and you're trying out different architectures.
Right.
You can monitor those TPU metrics during training, and that'll give you real-time feedback on how each design choice is impacting performance, memory usage, efficiency. It's like having this continuous feedback loop during development.
Exactly. You can make better decisions about the model's design.
So instead of just, experimenting blindly, hoping you stumble upon something good, you've actually got this data to guide you.
Right. And you know what else is really exciting about this? We could potentially automate some of this model development process.
Really? So we're talking about using these metrics to not just inform decisions, but to actually guide the development of models?
Exactly. Like, imagine if we could automatically search for optimal architectures, or even, adjust the model's structure during training to make it adapt to the data and the available resources.
That's amazing. And while we're not quite there yet, these new TPU metrics are definitely taking us in that direction.
They are. It's like we're getting these building blocks to create this new generation of AI systems. Intelligent, adaptive, really efficient.
It's almost like we're on the cusp of this whole new era of machine learning.
It is, where we actually understand how our models work and how to really get the most out of them.
I think we'll be talking a lot about these TPU metrics in the future. They're changing how we think about AI and how we develop these models.
I think so.
All this talk about optimizing training and building better models, it really brings up an important question. What are we actually trying to achieve with all of this? What's the end goal?
That's a great question. And it's something that we're going to keep in mind as we go forward. Mm-hmm. Technology is a tool, and it's really up to us how we're going to use it.
Right. And that's a conversation that we need to have alongside these technological advances.
Definitely. And we'll be exploring that more in the next part of this deep dive, so stay tuned.
Stay with us. There's much more to come. It's amazing to think about. These metrics, they're not just about speed or efficiency. They're really giving us this whole new level of understanding about how these AI systems actually work.
Right. It's like we're finally starting to peek behind the curtain. Getting a glimpse into how the model is actually thinking.
Exactly. And as we were talking about before, that understanding has huge implications for how we design these AI systems going forward.
Oh, yeah. Imagine if we could design models specifically for, a certain hardware. Mm-hmm. Optimize the architecture right from the start.
It'd be like designing the car and the engine together.
Right.
To make sure they work perfectly in sync.
Right. Instead of trying to, cram something in where it doesn't fit, we'd have this seamless integration between the model and the hardware.
And the benefits go way beyond just, efficiency, too.
Oh, yeah, absolutely. Yeah. Think about the ethics. Mm-hmm. The more we understand about how these models make decisions, the better we'll be able to address, potential bias or those unintended consequences that can happen.
Right. It's like having a responsibility manual for AI. If we're going to trust these systems to make important decisions, well, we need to understand how they're thinking.
Yeah, transparency and explainability. They're becoming so important as AI becomes more and more, a part of our everyday lives.
And that brings us back to the question that you asked earlier. What is the ultimate goal of all of this? these metrics. They're powerful tools, but we need to make sure they're used responsibly.
It really is a big question. It's like giving someone, a really powerful engine. It can do amazing things, but it can also, cause a lot of damage if it's not used properly.
So it's not just about the technology itself. It's about the ethics behind it as well.
Right. And that's a conversation that we need to have as a society. Developers, researchers, policymakers, everyone needs to be a part of that.
Because in the end, AI should be a tool that benefits everyone. And these metrics, this new understanding, they can help us get there.
They really can. It's an exciting time to be working in this field.
It is. And I'm really optimistic about the future. So thank you so much for joining us today and, shedding some light on these new TPU metrics and what they could mean for the future of AI.
Oh, it's been my pleasure. It's been great talking about this with you.
And for our listeners, keep that curiosity alive. The world of AI is always changing. It's up to all of us to stay informed and stay engaged.
Keep asking questions. Keep pushing those boundaries. Who knows what amazing things we'll discover.
Until next time, keep diving deep.